Welcome back, everyone, for the afternoon break. We have Firetail here, and I'm very excited to introduce founder and CEO Jeremy Snyder.
Hey,
Hi,
Mel.
Jeremy.
Hey.
Welcome.
Thanks, Mel. Happy to be here.
Happy to be here as well, and happy to hear you talk in regards to API security posture and to learn about your expertise. So I'm going to kick it off to you, and everyone, make sure to leave any questions or comments you have in the chat. Thank you.
Yeah, absolutely. Yeah, thanks so much for taking the time to join us today to talk about API security. It's a really important topic. We're going to get into some of the why it's so important towards the beginning of today's presentation. I want to start off today's presentation by just kind of setting the context for what we're going to be talking about today. You'll see that the title of the presentation is kind of two parts: learning from a decade of API breaches and why an application-centric view is the right path towards API security. I'm going to start by kind of setting the context for why API security is important. Then we're going to go through some of the learnings, and then we're going to talk about API security strategies, why that application layer visibility is so crucial, and obviously, we're going to leave time for Q&A towards the end. So I really appreciate if you do have any questions as we go, feel free to drop them in. Don't know if we'll be able to take them throughout the course of the presentation or probably more towards the end, but please do feel free. And if we run out of time or if I don't get to your question, please do reach out to me one-on-one. You can see my contact information on the screen here. I really do welcome emails from anybody who just has any questions. I'm happy to take them at any time, really. So a little bit about me. I've spent about 25 years in IT and cybersecurity. I actually started off as a practitioner for the first kind of 13 years of my career. When I say practitioner, what I really mean is that I was actually like building IT systems, running cybersecurity programs, first for a couple of SaaS companies that didn't necessarily start as SaaS companies. One started as desktop software and kind of evolved to SaaS in the early 2000s. Another one started very much as kind of an enterprise on-prem installation and pivoted to SaaS in the kind of 2005, 2006 timeframe. And then I ran IT, cybersecurity, and back office with a team at a video game company that was a metaverse only about 15 to 16 years too early before the metaverse became kind of a popular thing to talk about. So we were working on that all the way back in 2006. Suffice it to say, we were way too early, not only for the market, but also for the technology. A lot of challenges, but a great learning experience. I then kind of changed gears in my career and went into more kind of customer-facing roles, primarily around solutions architecture, design of systems, helping other customers build things similar to how I had done for the 13 years up to that point, largely in the cloud ecosystem, first with AWS, then a couple other partners. And I think the most interesting thing that's kind of brought me here to talk to you about API security today is really the last 6-7 years of my career, starting at a company called DivvyCloud, which was an early cloud security posture management software provider all the way back in 2016. Now cloud security posture management is part of a broader cloud security category that you might now see most often described as CNAPP, Cloud Native Application Protection Platforms. We were kind of early in that space, designing software that helped customers manage large-scale, fast-moving AWS, Azure, and GCP infrastructure as a service environments. That grew kind of a 20x growth rate in about a 4-year period, and then we joined a larger organization called Rapid7, where I spent about a year and a half working on M&A. Was part of a team that did 3 acquisitions in 2021. Fascinating learning experience. And really what I say about API security is that everything that I've done up till now in my career has kind of led me here. The reason I say that, as we get into it, I'll talk about this in some of the cloud API security strategy section, is that API security really is the next wave of security on top of cloud security. So that's really kind of what brings me here today. So hopefully that gives some background on kind of how I got into this space and helps to understand my view. If you hear things that I say and you think, well, that doesn't really match, just remember I'm coming to this from a cloud security perspective and a kind of an evolution of cloud security perspective. So let's talk about why API security is a problem and actually like what is the current state of APIs. Obviously, if you're here, you kind of believe that there is something going on with APIs. Otherwise, you wouldn't be investing your time and your energy into researching this area. But I want to kind of just frame how big a problem this is that we're dealing with. I think we all understand by now as technologists that APIs really are everywhere, and that, every time you pick up your phone and you use an app, there's not much happening on your mobile device. All of the real logic, all of the real smarts of that transaction is kind of happening at the back end. And the same is really true for every kind of IoT device, whether that's, a smart doorbell or a refrigerator or, an energy meter at an industrial scale. But we're also seeing APIs being the back end to things like modern web apps. Most SaaS companies that I talk to nowadays, when I ask them about their architecture, one of the first things they'll tell me is that it's decoupled. And they've got a front end that's typically written in something like a React.js, talking to a back end. And even the communication between two kind of web components is API driven. And we're seeing that, with web applications, with SaaS applications, even with kind of in-house proprietary applications that are really written for an enterprise scale or an enterprise architecture. We're seeing the same kind of pattern. We've got front-end UIs talking to back-end APIs, and hence the API really is becoming the backbone of the modern web. We're going to talk about some of the statistics around this as we go, but let's just kind of get into an example that I think really will help to make this concrete. So, I made this diagram in an online drawing tool, so it's not the most elegant kind of architecture drawing that you'll ever see, but hopefully it helps to serve the purpose of illustrating what I mean when I say that, any transaction that we initiate as a consumer probably kicks off more API calls than we really think about, right? So if we take this example of just a mobile food order, I may pull out my phone, I may flip through a couple of screens of menus, tap a few items, add them to my cart, and then either, use a saved credit card, use Apple Pay, input credit card details, what have you. And that kicks off a whole chain of transactions as a result of that, right? So I've now sent my order from my phone to some cloud service. That cloud service is now going to coordinate across multiple third-party providers and partners that they're using, things like the restaurant, right? And they want to transmit the order to the restaurant. They don't want to necessarily process my payment until they know that the restaurant is going to be able to fulfill that order. But once they get that kind of confirmation back, boom, then they want to actually process the payment before they confirm to the restaurant to go ahead and make the food, right? Once they've got that kind of coordinated between those two providers, now you need to bring in the third leg of the stool, which is the delivery logistics, right? And so now you're going to reach out to a fleet of drivers, and there may be some logic behind that. There may be a third party who actually coordinates the logistics here and figures out, who's the closest driver with available time in their work queue, who's the driver whose schedule aligns with this, who's the driver with the right mode of transportation. All of these different kinds of considerations that go into the business logic of choosing and confirming a delivery provider. And what we as consumers expect is we expect a seamless experience. We've pushed that one order button, and all the rest of this is just kind of magic to us. It's happening in the background without us really having to do anything related to it. It's all just kind of back-end processing magic. But what's happened as a result of all of these things is let's pause for a sec. Let's consider it. We've actually had now probably more than 20 API calls to execute a single transaction that could be as simple as, hey, deliver a cheeseburger to Jeremy at home, right? That is a very simple concept, but when you break that down into all the necessary building blocks to execute the application and business logic behind it, it's very complex. It has a lot of moving parts, and it also has a lot of sensitive data. Now, there's me as a user. You've got, my name, my email address, my contact details, my home address. You've also got my payment credentials, right? And all of that is being sent to third parties, potentially once, potentially multiple times, right? So we know that critical business transactions are also being processed in similar ways. We know that sensitive data, like, again, these PII, personally identifiable information, and payment processing information, all of that is being sent over APIs. So hopefully that kind of illustrates, the complexity of a lot of these modern applications, and it illustrates some of the complexity and some of the seriousness around the business transactions and around the data going through APIs and why it's so important. When we put that into the context of the broader web, I think this quote at the top is really illustrative of kind of where we are on the modern internet. There's some very interesting statistics around the volume of overall internet traffic and the fact that more than 83% of internet traffic is just API calls. So it's not, me Googling something. It's not me pulling up a website. It's actually, me making that order that then kicks off all of those API transactions at the back end. So it's computer to computer, application to application, system to system communication. And we're on track to having 1 trillion programmable endpoints. The momentum behind this, as I said at the beginning, I came to this space from cloud. And we see here, the momentum behind containers, serverless, multi-cloud is really pushing the increase in APIs. A couple other things to think about in the context of the overall API landscape. One is that private API volumes are actually larger than public API volumes. So for every kind of, let's say, third-party provider that you interact with who has public APIs, underneath the surface, they've got more private APIs to serve that public API service than they expose. We already know that there's something like 200 million public APIs on the web, growing to 1.7 billion in the next kind of 7-year timeframe is the projection. If we think about the pure API economy, which is to say companies that provide their functionality or their data as a service powered by an API, there's already more than 50,000 of those on the web, with 40 more public API services being added every week, according to some research that provides it, right? So we've got critical data, critical transactions in a huge modern internet of APIs talking to each other. And I think, if you haven't had a chance to check this out, this is a report from Akamai back in 2021. They do an annual State of the Internet report. And in 2021, they really highlighted that the API is the attack surface that connects us all because of all the reasons we've just gone through. I won't go through that, but I just wanted to take a minute to call it out. It is a very, very illustrative document. It's very informative. So if you're here and you're interested in this space and you haven't checked this out already, I would really encourage you to go do so. How did we get to the current state of APIs? I did want to take a second to kind of talk about where we're at, because some of this will be really relevant when we get further into today's conversation around the technology side and around security strategies. We went through the start of API logic actually all the way back in the 90s. We didn't necessarily call them APIs at the time. We talked about things like electronic data interchange, EDI. We talked about Web 1.0. We had very much kind of data center, colo facility type of architectures, meaning we had monoliths. We had bare metal machines that, might have been connected directly to the internet, might have had maybe a firewall in front of them, but had open ports to connect directly to those servers. When we got into the 2000s, we actually had Microsoft leading the way on the kind of transformational wave of APIs at that point, or as they were really called back then, web services. So if some of you are kind of similar age to me, you might have actually been present for that wave and to hear about things like SOAP and XML and, kind of getting away from this terrible EDI format that was so huge and inefficient. We got into more kind of, structured documents with tags and markdown formats and so on. We were still more of a client-server architecture, really where you would have, kind of one monolithic server and multiple clients connecting to us. And we got, kind of for the first time, we got virtual machines at a large production scale. And then when we get to where we are today, kind of in the 2020s, we're actually talking about, kind of REST and GraphQL as the primary kind of API application models and application interfaces. We're very much in a distributed API-centric world, and I won't reiterate the points that I raised earlier around this, but I think from an infrastructure perspective, one of the most interesting things is to see that, most of the organizations that we talk to nowadays about where they are with their APIs and where they're running them, they may still be running on virtual machines, but when you ask them, hey, what's your plan for where you're going to be running your APIs over the next few years, we're seeing a real push towards serverless functions and containers and a move away from kind of running virtual machines at large scale. So we're at this kind of evolutionary cusp. There's a lot of change going on, but it is still a really, really interesting time with a lot of technological development. Great. So hopefully that gives some background for, why APIs are so important from that criticality and data sensitivity perspective, and then why that's such a big problem from the overall kind of internet trends and market perspective. So let's talk about what we've learned over the last kind of 10 plus years of API data breaches. One thing I'll point out as we get into this, we've got some research on our website. I will share the URL in here. Obviously, otherwise you can just find it directly on firetail.io. If you're looking for it, you go to our website, just go all the way down to the bottom in the footer, you'll find the API data breach tracker. That's where we've been collecting this. But one thing to kind of kick off the conversation around this decade of learning, the very first API-based data breach, or the very first kind of data breach that we could find publicly documented, where the data came out of an API, was back in 2011. So about 12 years actually of API-based data breaches. Well, with the scale and the context that we talked about, we know that APIs are a problem. We actually had a prediction from Gartner that last year would be the year that API abuses would become the most frequent attack vector. Here we are in 2023. I will tell you that did not happen. We've done a lot of research around data breaches from last year, both in terms of, let's say, number of events, in terms of number of records, in terms of financial impact. And what I can tell you is that we are still in a world where the number one attack vector for most organizations is going to be the human, which is to say, phishing, credential theft, breach of an individual endpoint owned by a human who makes a mistake in terms of opening the wrong document, downloading the wrong document, getting a piece of malware, getting a local infection, all of that kind of stuff that you can broadly categorize into the individual user / individual user endpoint. That is still the most frequent attack vector. So I do want to kind of be clear. We at Firetail, we don't really like to sell on kind of FUD, fear, uncertainty, and doubt, and kind of plant it in your mind that, this is the sky is falling, the world is coming to an end around this. We want to put this in a real kind of risk management perspective. You should understand the risk of your organization, what you're transacting over APIs, and then prioritize appropriately. But what we have seen is that, API sprawl is a looming threat. So APIs are becoming the low-hanging fruit. Let's explain that, and let's put some kind of context around that so we don't kind of draw some of the wrong conclusions. What we have seen around API sprawl is that organizations will very often create a public API service. They might version it, and then they might create further improved versions, but never retire previous ones. So that's one common problem. Another kind of API sprawl problem that we have is that in order to create more services or to expand the functionality of services that already exist, additional APIs and API endpoints get created without documentation and without visibility from network or security teams. And so that is kind of what we think about as API sprawl. This is very, very similar to what we saw going back 6-7 years in the cloud security world. We saw a lot of adoption that got ahead of security teams on cloud, and we see the same patterns play out again with APIs. So that's that API sprawl kind of message that I would share with you. The attacks have grown. There's a lot of ways to kind of measure some of the statistics. So that 348%, we're going to get into a little bit of that when we go close to 1 billion records. Again, a little bit of nuance. We'll get into that a little bit more. But what I do think is important to take away is that vulnerability in applications handling APIs are the direct cause of the breaches. So when we think about kind of security strategies, or we start to analyze, how did these breaches happen, just know that it always comes back to the application layer, into kind of vulnerabilities in application handling. So we'll talk about that in a little bit more detail as we go, but that should kind of help set the stage. Recently, there was a survey of CISOs, Chief Information Security Officers, around, what are the problems that they have? Well, we hear some of, again, the common things that we saw with cloud security a while back. Lack of API inventory. Excuse me. So we talk about sprawl. We talk about technology adoption getting ahead of maybe internal coordination with security and network teams. Boom, we've got that same kind of symptom again. Perimeter security. Just like the shift to the cloud, where a lot of organizations struggled with understanding what is the perimeter in public cloud, we're seeing that same thing play out with APIs. And I think the interesting thing here is that there are multiple kind of perimeter, let's say, mechanisms or controls that you can apply on top of an API. So that could be things like API gateways. And those are really kind of software constructs more than they are network constructs. They may present as a network topology item and route traffic through them, but they're not the same kind of, let's say, firewall logic that we would have previously seen with perimeter security. So that's another thing that we're seeing from CISOs. And why that's a challenge? Well, it's because their teams are used to dealing with firewall type of logic, not with gateway type of logic. And now understanding what kind of functionality goes on each is a new learning experience for them. Number 3, end-to-end tracing of code to API. We go back to that point for a second where we just talked about the fact that vulnerabilities in apps handling APIs is the prime problem. Well, if you've got a problem with an application, how do you find that application? So you need to be able to say, like, from my, let's say from my code repository to my application in production, how do I figure that out so that if I do have an application problem, I can go back to the actual code or the developers who own the code. Number 4, number of required security configurations. This is a really broad category of problems. This is that's reported here. Organizations struggle with security configurations about their cloud environment. And as we discussed earlier, we're seeing a lot of API development specifically in cloud environments. So that kind of challenge of, where is my API logically? Does it have the same kind of network perimeter controls? Well, no, because it's on public cloud. So what does that mean? What about some of the other elements that it's connected to? Things like, let's say, database as a service, storage assets, and so on. Those become real challenging security configurations to track to gain like a contextual picture of the security of an overall application. API change management, this is more of a symptom of again, fast-moving development teams getting ahead of security, and then, that gap between developers and security. That gap between developers and security, we've talked about like the technological side of it, which is that a lot of the times development teams get out ahead, but there's also the cultural aspect. In a lot of organizations, you've got a communication gap between those teams. So it's not just kind of a technology adoption gap. It's one team doesn't like the other, so they don't share information with each other. So those are the top 6 problems that we've seen. We'll talk in a little bit about how we try to address some of those problems here at Firetail, but let's get into actually what we've done from the breach analysis perspective. I threw out a statistic a minute ago about 1 billion records breached. Actually, our own analysis shows that it's not quite that high. It's 577 million. You can look at that in various ways, but that's what we've got so far. We do have an average of 13 million records per breach event. And I think this is actually really meaningful in my perspective, and it really stood out when we did the analysis. Why is this meaningful? Well, when we look at a lot of breaches, they tend to be much more localized and smaller scale. Why is that? Well, that's typically because you've got breaches that happen against other attack vectors, a local endpoint, a laptop owned by one user, etc. Those things tend to be kind of more segmented and more easily separated. What happens with API breaches is they tend to be logical flaws that expose entire data sets. And when we think about, data sets that could be millions and millions of records, that's why we end up with numbers that are so large. And if you look at our data breach tracker, you'll find a number of incidents that are, easily 10, 20, 30, 50 million records plus. We've seen 43 unique documented breach and research events. The key difference between a breach event and a research event is that a research event largely is something that was discovered, reported to the organization, and remediated, and then disclosed after the fact as a responsible kind of reporting process, allowed the organization a chance to remediate an API security vulnerability before it had a chance to be exploited. But they uncover some very, very interesting information about, kind of some of the attack vectors, some of the breaches that are possible, and so on. The top attack vectors we're going to get into in just a minute here in a little bit more detail. So let's talk about that. We've categorized all of the API breaches that we know about by doing a little bit of investigation and reading and kind of plotting them on a chart against some of the top things that we know about, both from the OWASP API top 10, which if you've been attending previous sessions today, I'm sure you would have learned more about, and in terms of kind of, some of the categories that we came up with a little bit on our own. Authentication and authorization, as you can clearly see from this diagram, are like far and away the top attack vectors. So let's talk for a second about what those really mean. The case of authentication is usually one of a few different problems. One is that you'll see some APIs where, either they just did not require authentication because they were going through kind of security through obscurity, or they didn't require authentication because they were public APIs private APIs that accidentally got exposed publicly. That's another. Or there are things like API authentication relying on something like a certificate that can be easily extracted from like an Android app. Or there are APIs where the authentication algorithm was weak and things like credential stuffing can succeed against them. So that's a huge category on its own. Authorization, a very large one as well. Authorization, you would have heard from the OWASP Top 10 about 2 to 3 categories, depending if you're looking at the 2019 or the 2023 release candidate. That would be things like broken object level authorization, broken function level authorization, or broken, I think it's object property authorization. So all of those together kind of constitute that authorization category that we're talking about here. But we see very little in the way of things like brute force. We do see injection, and we do need to think about that. But we see more kind of configuration governance. Enumeration is one that I'll call out real quick because I actually think that this is a particularly interesting category. It's not a huge number, but it is an important number in the sense that we're right on the cusp of more technological change in the API landscape. I talked earlier about kind of REST versus GraphQL. For those who aren't really aware, I'll just take a second to kind of explain what I mean there. REST is a very constrained API call, right? You've got certain parameters that are either expected or required for an API call, and that REST API will return only the data elements that are requested, and that can be returned by that endpoint. Well, that's very limiting, right? And that might actually have a lot of maintenance costs to keep up with that. And every time we need to expand the response payload with additional data fields or so on, we have to go through an API iteration. That can be very time consuming and very costly for both the API owner and for the, let's say, API consumers to keep up with. And so GraphQL is kind of an alternate approach that allows for more free-form queries against the data behind APIs. And so, that allows for a lot, but it allows for a lot. And so, the challenge there is, are we exposing potentially too much data? And what we've seen in some enumeration attacks is that attackers are actually aware that GraphQL endpoints potentially expose a lot more data. And so they're doing a lot of kind of probing and enumeration around APIs that they discover. In our own lab, we stood up a couple of API-driven applications, a couple of public APIs that we put on the internet. And we've seen that more than 99% of the traffic against those APIs is searching for GraphQL endpoints, searching for admin endpoints, searching for credentials through trying to trick it into exposing environment variables, config files, anything like that. So that enumeration category may seem like a small number, but we think that's actually going to grow with the rise of GraphQL. One of the other things, though, was that we realized that with almost every API data breach that we found, there's actually multiple attack vectors. Kind of two things went wrong. So you would see like authentication and authorization together leading to a breach. But actually some of the other categories that we see are really things around utilization and governance. And when I say utilization, what we really mean is like, has this API been abused? Is the API sending back more data than it should be in the response payload? So you would see again from the OWASP things like mass assignment or excessive data exposure. So we see a lot of that. We see more governance around, organization didn't have visibility onto a particular API, so they weren't paying attention to it until after it was already breached and so on. So just bear that in mind. And I kind of the analogy I like to give around this is, I'm not sure if any of you have ever read Malcolm Gladwell books, and I can't remember which one it was, but he sadly talks about airplane crashes, and that in most airplane crashes, you actually need like 7 things to go wrong that lead to the crash. And quite a lot of them are human errors, but you need technical errors compounded with human errors for things to happen. And similarly with APIs, there are very, very few API data breaches where you could point at just one thing and say like, oh yeah, they did this wrong. And if they had done that right, everything else was perfect, boom, it's really down at one attribution. Actually, what we see is quite the opposite. We see, it's a combination of network security configuration plus unauthenticated API. It's a combination of, public API that didn't check for authorization post authentication, right? Like there's a lot that goes into these breaches. So just bear that in mind. Almost all API breach events are multi-vector. So when we think about that, just kind of another view on this, breaking it down: authentication, authorization, data handling. These are secondary breach vectors, so bear that in mind. It's just another view on that last chart that we looked at. A little bit more when we kind of zoom out and we say, like, well, who is this happening to? What types of organizations? It's not industry specific. APIs are everywhere, but a few industries have had huge breach impacts recently. Manufacturing, in particular, automotive. You can look back in the last couple of months and you'll see a ton of stuff around connected cars and just how weak the APIs are, or things like partner ecosystems and how weak the APIs are there. I won't call out any names specifically, but you can have a look at our breach tracker and you can actually go find for yourself if you're so motivated to do so. But just know that if you have a connected car, hopefully you're getting an over-the-air update, or you may want to, give a call to your dealer and find out if there is an update that you can get to make the connected car system a little bit more secure. Of course, technology companies, of course, software companies who are, building APIs, consuming APIs, et cetera, are a huge part of the industry impact. And then one that I find a little bit troublesome for me personally, because I do travel a lot for work and for leisure. The hospitality industry has been, subject to a number of high-profile, large-scale API data breaches. Airlines, hotels, rental cars, all of them. And it actually kind of makes sense if you think about how these industries work. When you book travel online, you've got a lot of affiliates, you've got a lot of partnerships, you're doing a lot of third-party bookings and integrations and so on. So there's a ton of API exposure in the hospitality industry. And consequently, we've got breaches. We've taken the trend lines from the last couple of years. We've looked at some of the data breach events. 2021 had a spike because of some very, very large scale breaches in 2021. But what we've seen is, kind of picking back up. We're seeing an increased projection for this year, 227% breach acceleration, meaning number of breach events year over year. And then we're projecting that the average number of records breached is going to be high. Getting closer to 3 million. So a little bit below that historical average of 13 million over the last 10 years. That's kind of heavily skewed by some of those larger ones, but still, 3 million records per breach is, again, more of that kind of systematic breach or systematic weakness that I mentioned earlier. If you want the data, you want to have a look, feel free. It's at firetail.io/API-data-breach-tracker, as you can see on the screen. Feel free to go check that out. As I mentioned, it's linked from the footer of our website, and you can get more information there. So let's talk a little bit about Firetail and about API security strategy. So at Firetail, we like to talk about API security as being as easy as, import, setup, done. That's really how we've tried to design our solution. We've got a hybrid API security solution. We've got both kind of agentless and agent-based. I'll talk a little bit about what that means and kind of how that could be impactful for an overall API security strategy. We deliver an API security library that is open source. You can drop it into your application code. What does it do for you? It's going to check for authentication. It's going to check that your authentication is actually in place. In real time, it's going to check whether the authentication that we're seeing from an API call conforms or matches with the authentication that you expect in your API specification file. Authorization is kind of a coming soon. So actually, I won't say too much about that today, but we are working on a solution to that authorization problem of who can do what. So those OWASP top 10 problems around broken object level authorization, function level authorization, we're working on a solution for that. We're also working on kind of a validation that, that's already live. The validation and the anti-enumeration, that's already live. And then sanitization for data types going in or out. We've got some nice regular expression evaluators that help you just check, do a sanity check that all the request parameters coming in match what you expect them to be and aren't kind of injection style things. And we can also do some sanitization of payloads going back out. We've got some great use cases there for overall visibility, centralized audit, and so on. So if you're interested in any of that, please feel free to hit us up. We're really trying to deliver like kind of an end-to-end user journey around API security, whether that is for the developer or for the information security team. We allow you to kind of discover your APIs, bring visibility to them, bring observability to them. So you actually get some nice timestamp telemetry data off of your APIs. And then we bring real-time enforcement coupled with kind of policy enforcement and centralized audit. So that's some of the stuff that you can get from Firetail, the core principles that we really provide for you. As I mentioned, kind of the journey really starts for most customers that we've worked with so far, really starts with the discovery and inventory step, goes through policy analysis and assessment, and then brings in attack prevention and runtime protection along with that centralized audit. Why is this important and why did we kind of build it this way? Well, when I was working in the cloud security space, one of the things that we would get asked from customers a lot of the time was to help them understand how they could design holistic approaches to cloud security. Excuse me. And very often when we would say, well, what does that really mean for you, a holistic approach? They would say, well, it really means end to end. So if you look at this kind of blue arrow across the bottom, think of that as your timeline. You're starting on the left-hand side and you're starting with, code in your design phase. So what do you want to do in that phase from a security perspective? You want to make sure that you're writing secure code and that you're getting rid of vulnerabilities from things like third-party components that you're layering in. When you get into kind of pre-launch and you're getting closer to going live, maybe you want to do some fuzzing, maybe you want to do some DAST, SAST, or IAST, some kind of security testing of your application. But you also want to test like application and business logic, which really requires interactive and, maybe you can automate, but maybe you also need automation plus human testing there. And then when you get into runtime, what are you doing for something that's up in production? Are you covering the attack vectors that you need to be covering? Do you have the centralized logging turned on that you need to have from an audit or regulatory perspective? And also to enable you to do kind of detection and response stuff. When you think about that layered onto a technology stack, you've got kind of, infrastructure layers, you've got application and operating system layers, and then you've got API layers on top. What we realize is that what we're trying to help you do is build API security in to the code layer, and that pushes all the way through into runtime. And you get both kind of the agent-based version that is at the API layer and the agentless version that aligns to the infrastructure layer. Happy to talk about that in more detail with anybody who wants that. But let's talk about why you want to embed into the application layer. We've done an analysis of, we used AWS as the example here, but we've done an analysis of API calls on AWS platforms to try to understand all the different things from an API call that you can see, whether you're looking at it from, let's say, an API running on EC2 where all you get is VPC flow logs. Maybe you're looking at an API sitting behind an API gateway or a WAF, or maybe you're looking at the application layer. And what you'll see here is that, it's only the application layer that lets you check all these things, including response payloads. You get visibility into them, and you can then take appropriate security actions on those data elements. So that is why we're so passionate about looking at this from an application perspective, because we think that's really where the problems are. I won't actually go into this in too much detail right now, because I know we're getting close to Q&A time, but just bear in mind the logical flow, as I mentioned earlier, really centralizes around those primary attack vectors. Here's an example of an API event log. You do get the full call logged. You can actually choose to obfuscate certain fields or not include certain fields if you think that's sensitive data. It's completely up to you. Couple configuration changes. We do capture all of the HTTP response codes, whether success or error, and then you have the option to log that payload. You can have that logged to our cloud platform, which is kind of the default setting, or you can redirect the logs locally if that's what you choose to do. And again, timestamp telemetry around that. Awesome. This is kind of the architecture. If you do use the end-to-end solution, you've got kind of, any of the AWS infrastructure components that you're using. You've got your own application library. Then you've got the Firetail library, your application code, the Firetail library. You drop a key in there, boom, sends that to our SaaS platform for anybody who's interested. Kind of the last thing that I will leave you with for today is that we do actually offer both commercial and open source. I've kind of mentioned the open source a few times, but that's the library. You can go on GitHub. You will find a few different language versions that we support already. You can actually, have a look at the code there. Feel free to download, deploy them, etc. If you need any help with that, we do have developer support available. You can just reach out to support@firetail.io. There's also a chat function on our website where you can contact our customer support team. And then finally, we actually offer commercial trials, obviously free of charge. And we have a kind of a free single user plan. So if you're here as an individual practitioner, building, let's say, your own 1 to 2 person startup, and you've got just a couple of APIs, feel free to sign up for our free plan. You'd kind of fall into that tier of usage there if that's what your size and scale is like. And I think with that, I have reached kind of the end of what I have prepared for our presentation today. But thank you all very much. Feel free to hit us up, jeremy@firetail.io. That coming soon is, sorry, that's old. Our website is online. You can see all of that. I grabbed a thank you slide from an old presentation and forgot to remove that out of there. But thanks so much. I'm happy to take any questions at this time, Mel.
Thank you, Jeremy. Fantastic presentation. Really love the detail of exactly what you're trying to do to basically secure and to help with API security. You mentioned some really great statistics, which I think I'm actually going to go and check out, because I can't get over how much has changed over the years, right? So real quick, from a executive standpoint, you mentioned a lot of good points as far as preparing an organization or an entity from threats and how to do that. So there's many ways, right? You can monitor it. There's asset inventory on how to actually keep track and catalog those APIs. If somebody were to ask, how do I begin? How do I start? It's a little overwhelming, right? But you need to make sure you have certain tools in place. No one really knows, what do I have in my environment? What would you gauge them to do?
Yeah, I mean, there's kind of an old truism in cybersecurity, which is that if you can't see it, you can't protect it. And so, a lot of the times I tell organizations, if you're going to start anywhere, start with visibility. That said, visibility doesn't always mean the same thing for organizations. For some organizations, visibility could actually just be a set of internal conversations where you pull in all of the API owners, all of the application team owners, and you build an inventory internally based off of what they know of, what they report, what's in their code repos. For other organizations, that's going to be more of a technical analysis where you put, some kind of sensor in a cloud environment or on a network, and you observe communication traffic and patterns, and you look for APIs from that perspective. And for others, it might be a little bit of a combination or a hybrid or something in between. But I always tell people, start with visibility, because that's really the first thing that you need to understand is, what APIs do you have? And then from that standpoint, you can then, or from that starting point, you can then go, do some observation, and you can figure out which ones are high risk, which ones are high value.
No, that's a great point. How long would it take, somebody with no, let's say you have an engineer, they've been in IT for a while. How long would it take for them to really understand and baseline what they have in their environment? I mean, I want to say, I think that's kind of the hurdle that everyone is so, used to, network monitoring, endpoint monitoring, you have APIs. And how do we really escalate that awareness to not just the operations team, but also to the executive team on, hey, this is a threat. It's happening. Like you said, Akamai had some really good statistics about it. And how do we raise an awareness, right?
Yeah. Look, I mean, I think starting with those statistics is always a really good thing. And, one of the things we tried to do with our data breach tracker is actually put those things out there, make them very readily accessible. And even just the fact of centralizing all this stuff in one location makes it easy for you to go look at. You can look at that list and you can kind of pick, whether it is, let's say, the industry you're in, whether it's a description that resonates with what your own architecture or your own business is like. Start there. Maybe grab a couple examples that you want to take and present to your management. That I think is an easy way to start. One other thing I'll kind of plug here, we don't have it live yet. We're actually working on a state of API security report that goes into analyzing this breach tracker in a lot more detail. We'll be releasing that in the course of the next month or so. So here we are in March of 2023. So sometime in April of 2023, we'll be putting that out. That'll also be, some great data consolidated, a little bit of analysis around it that anybody is free to, go grab, download, and use for whatever needs they might need.
Perfect. No, it's great information. Aside from, the basics, you mentioned some really amazing things like data exfiltration. I mean, cross-site scripting, you can easily, through an API, send data elsewhere, right? So
Yeah.
I think that's key, right? There's some like exploitation of authorization, logic, and also accidental data exposure. All
Yeah.
great threats and vectors in the environment. Going into some of the governance side, where
Yeah.
how do you really talk about API, for example, PCI DCS compliance or API
Yeah.
HIPAA compliance? How are some
Yeah.
ways we can gauge those individuals and say, hey, look, did you do these checks, and are you really protecting your environment?
Yeah. Those are really, I call those kind of, let's say, like phase two challenges to think about, right? With phase one is really kind of visibility and just understanding what APIs you have. The second part of that, to your point about kind of governance or let's say regulatory compliance around, PCI or HIPAA, you actually really have to get into that next level of visibility, right? So you not only need to know that you have APIs on the network, you need to know what kind of data is going over those APIs. And that's again where you kind of have to have that higher level of visibility. Like if you don't know what data is included, you can't possibly know whether that is in or out of scope for something like PHI, personal health information, that would be HIPAA regulated versus things
Right.
that aren't. And so, that's where I say, like, you've got to kind of try to you've got to try to bring parts of the organization together that may historically not love working together. So things like application owners and security. You can do that through teamwork and collaboration and conversation. You can do that through technical controls and observability. But one way or the other, you actually need to get into the layer where you see the data elements that are being transacted. Otherwise, it's pretty much guesswork. If you're trying to say like, oh, this API would be in scope for a HIPAA audit or something, or this one would not.
Right.
That is where you've got to try to get that higher level of visibility.
No, perfect. Yeah, I'm always concerned about that because you have security, then you have governance, and they kind of have to work together, right?
Yeah.
So completely get it. It's a tough balance, but you also want to make sure you have the right logs and monitoring in place, and then you're also being compliant.
Yeah.
Last thing before I let you go, because I'm really enjoying this conversation. What about reporting?
Yeah.
That's one of the things that operations teams, engineering teams lack, and that's something that the can really take the information and really turn it into an ROI for your executive teams. So, what are the best KPIs or reports that are most valuable to easily get, from APIs, right? To actually show
Yeah.
and actually translate that story and say, hey, this is where we were in a snapshot of time, but this is where we are 6 months from now, and we are secure, by
Yeah.
implementing a solution or by actually doing these things.
Yeah. Look, it's a great question, and I'm going to have many thoughts for you. So bear with me because you're about to get a little bit
No
longer answer
problem.
than you may be asked for here, right? So first, let's start off with kind of the basic side of it, which is back to the visibility perspective. Now, one of the things that I would argue for a lot of organizations is first, like, just at a high level, where do you think you're running APIs? Okay, is that on your on-prem network? Is that on your AWS environment, your GCP, your Azure, et cetera? So start from the standpoint, from a reporting perspective of, do I have observability in place across all of these places to know whether, somewhere on these networks are APIs that are transacting either publicly or maybe east-west internal API transactions. So that's one. And you can actually start from the coverage of like, a lot of organizations we talk to nowadays will ask them like, well, what's your AWS footprint like? And they'll say, hey, we've got 200 AWS accounts. Okay, well, maybe first thing you start with is, do you have coverage for all of the AWS accounts that are production? Right? So start with that. And you can measure that as a percentage of accounts, a number of accounts, whatever it is. But start from like, do I have observability across all of my potential production environments where I have APIs running? So that'd be like my first report that you would look at. Very easy report. Could be a percentage, could just be like a 5 out of 8,
Sure.
right? Like very easy kind of report. Second thing I would look at is, once you've got that initial visibility, what are you trying to think about as a baseline for your APIs? That can come in many different flavors. There's things like the OWASP top 10 that we've talked about, until we're blue in the face. That can be, one of the ways that you measure it is like, hey, are we checking each of these APIs for those things? What is maybe the percentage of our APIs where we've got those checks in place? And we might put those checks in place with things like, pre-production logical testing. We might check them with like runtime observability. However you're looking at that, you could even check them just from like a code and design standpoint. Like, try to get comfortable with how much coverage you have relative to some baseline. In the cloud security world, we used to use things like the CIS benchmark, the NIST cybersecurity framework. We don't have those types of really mature control sets for API security yet. They will be coming, I'm sure. But start with what you can do. Maybe you even just build an internal set of like, our threat modeling tells us that our primary risks around APIs are authentication, data exposure, blah, 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 blah. And so, maybe just a checklist of that. And again, measure that over time. So as additional APIs get brought online, like make sure that they get incorporated automatically into those reports and those things get generated regularly.
That's a great answer. Love it.
I've got one more thing to follow on that. The next thing that I've heard consistently is a real challenge for organizations around reporting is APIs are kind of a funny thing because they're like partially an application construct, but they tend to get exposed through some kind of network interface. Well, they always get exposed through a network interface, but that network interface may not be directly at the app layer. It might have like a layer in front of it, like again, an API gateway or a web application firewall or something. To that end, and by the way, like they're also funny from the standpoint that they're just like a little bit of application code typically, and with a whole bunch of business logic underneath them. They can be running on top of a bare metal. They can be running on my laptop. They can be, hopefully my laptop not in production, like that's a very bad practice, obviously. But they can be running on a virtual machine. They can be running on a serverless infrastructure. They can be running on a container of any flavor, etc. Here's the problem. All of those things send their logs to different locations by default. And so like one of those reporting problems that we've heard really consistently is, what if I have a breach on one of my APIs? What do I do about it? And like typically an incident response team, the first thing that they're going to want to do is get all the forensic data together in one location. But if the first thing that they have to do is go down a big ass checklist, excuse the language, a big checklist of like all the places that you could be running an API, and then like go through a process of elimination to, oh, okay, it wasn't this virtual machine. It wasn't this virtual machine. No, ideally what you want to do is you want to position that for success so that, you can have a breach or an incident report very quickly that says, okay, it was this API, it was running over here. We've got all of our API logs centralized in one location. We know what we saw. We know how many records went out. We've got, let's say, the response payloads that went out. We can look at those in great detail. Like to the extent that you can provide that to your teams, the quicker incident response you're going to have, the more thorough incident response you're going to have, the better results you're going to have from that. That is one of those reporting challenges that we really are trying to solve by providing this open source that will centralize all API call logs.
Love it. And I love the fact that, especially from an incident response standpoint, the number one question is finding patient zero. Where did it actually occur first? So having a centralized solution and one pane of glass versus disparate tools and having to go and pull it from all these different places makes that incident responder's life easy. And you mentioned something that kind of got my brain turning a little bit, where you're saying follow process, and you mentioned CAB in the past too, like a change control board, right? So you want to ensure that a lot of these things are happening during that process when you're bringing on a new API, bringing those developer teams together, the security teams together, and really ensuring that they're talking, communicating, versus having to go and respond to an incident after the breach took place. So I think having these methodologies in place, having these tools in place, gives some process, gives a tracking record, and actually like tracking exactly what's happening over time as they're learning the environment, right? So I think that's key. And you mentioned all these great different points. Anything you want to add to closing? I really enjoyed this conversation, Jeremy. Your presentation was excellent. And as an operator and practitioner myself, I found it very beneficial, especially when it comes to different parts of the operations team, the engineering team, how you deploy it, how you onboard it, and of course, how do you capture the reporting. So I think you've got that long, roadmap, so to speak, and how to enhance it, because as you know, this we're going into this world of everything is IoT, everything's connected. So actually taking that to the next level and showing the ROI over time, whether it's quarterly or yearly, that's what we really need to prove to the board is, can we continue to, translate those dollars and to continue my program, right? So just want to leave you the floor for the last few minutes and then close it off.
Yeah, well, two things to kind of close it off. One, I just saw a question here pop up from the audience. How do we detect against these OWASP API vulnerabilities? So, the first thing is there's an observability element that can kind of monitor API calls. It can be passive, it can be active. That's up to you. That's a configuration setting on your side on how you want to integrate Firetail and use it. You can also use Firetail's libraries to read your API specs and enforce in that method. So that is to Vanille in the audience. Feel free to hit us up if you want more information on that. But I want to kind of take a second to talk about, what we see is coming next, Mel, because one of the things you said really kind of touched a note with me, which is around kind of the roadmap around this. Look, we're still in the early phases of API security. We have seen a number of high profile breaches over the last couple of years. We've obviously spent a lot of time from our side here at Firetail to try to analyze them and to try to figure out, what went wrong. Maybe a little bit of the 5 whys analysis, maybe a little bit of the kind of, follow the implications and the logical flow of what we know from these breaches. Obviously, we can only go off of what's been publicly disclosed or where there's more information available through talking to people involved and so on. But what we've seen is like the initial attack vectors are relatively straightforward. And when we look at, kind of the real causes of them, authentication, authorization, data exposure, enumeration, like we know kind of categorically where this stuff is coming from. There are two things that from our standpoint are really, really crucial to understand. Number one is that we actually think these attack vectors are going to evolve over time. And we think that there's going to be more kind of breaches and more kind of logical exploitation. All of the emerging stuff that we're seeing is really around kind of data queries, data abuse of APIs. So these are not things that will look like, let's say, attacks from a network perspective. These are things that are going to look like normal API calls. And yet they're designed to kind of extract maximum amounts of data from APIs in unauthorized or unauthenticated or really like just not intended ways. So that's one thing we really want to understand. And so what that means for us at Firetail is our roadmap is continuing to evolve as we discover these new attack vectors. And we're going to continue really emphasis on kind of both sides of the solution because we know the code library is not right for everybody, but between an agentless approach and a code library approach, we should have you covered on either side. So that's something. Then the last thing I want to kind of leave the audience with is authorization being such a huge problem. Stay tuned. We've got some really exciting developments in the works right now around authorization, where we're really going to try to make it a lot easier for the people either building APIs, for developers, application teams, or the people running APIs, let's say on the infrastructure side, to get observability and to get potential blocking, like real-time blocking of unauthorized API usage. It's a hard problem to solve. We're really excited about some of the stuff we've got cooking up in the lab. So stay tuned to this space. And actually, we're hoping that later this year at API Days, we'll be able to share some stuff around that.
Fantastic. Jeremy, you just answered a lot of my questions and my follow-up. Really enjoyed speaking with you. I want to just let everyone know if you have any additional comments, put them in the chat, or you can reach out to Jeremy Snyder himself. He gave a link and
or come to our virtual booth and hit us up there.
Fantastic. Thank you again, Jeremy. It's been